Hello everyone, my name is Aseem Raghav from DTU Mechanical Engineering. My roll number is 2K13ME051 and I've been tasked with speaking on the topic of fuel injection pumps. So I'll be explaining in the next 5 or 10 minutes the working as well as the classification of the fuel injection pumps. So here it goes. The fuel injection pump is one of the most vital components in the working of CI engines. The engine performance characteristics like the power output as well as the fuel economy is greatly dependent on the fuel injection pump. It is dependent on the how the fuel injection pump is working and the effectiveness of the fuel injection pump. The injection pump has to perform the important duty of initiating as well as controlling the combustion process. So basically, the purpose of carburation and fuel injection are the same, the preparation of combustion charge. But in case of a carburation fuel, but in case of carburation fuel is atomized by the process of relying on the air speed being greater than the fuel speed. In the fuel injection pumps, this case is exactly the opposite. The fuel speed is greater than the air speed, and this is the basic working principle of the fuel injection pump. When the fuel is injected into the combustion chamber towards the end of the compression stroke, it is atomized into very fine droplets. These droplets vaporize due to the heat transfer from the compressed air and form a fuel and air mixture. Now, due to continued heat transfer from the hot air to fuel, the temperature of the fuel droplets, of the atomized fuel droplets, reaches a very high value, which is higher than the self-ignition temperature. This causes the fuel to ignite spontaneously, initiating the combustion process. So, what are the functional requirements of a injection system? I'll be moving on to this now. Now, for a proper running and good performance from the engine, the following requirements must be met by the fuel injection system. These are accurate metering of the fuel injected per cycle, timing of the injection of the fuel correctly, proper control of the rate of injection during combustion, proper atomization of fuel, proper spray pattern to ensure the rapid mixing of fuel and air, uniform distribution of the fuel droplets all inside the combustion chamber, and there should be no lag during the beginning and the end of injection, that is to eliminate the dribbling of fuel droplets into the cylinder. All these points that I have just mentioned are the requirements, are the functional requirements of injection system, and the injection system should be basically be able to accomplish all the things that I have just said. Now, so the injection system is basically classified into two types of injection systems. These are air injection system and solid injection system. Now, in uh, in a constant pressure cycle or a diesel engine, the only air is compressed in the cylinder and the fuel is injected into the cylinder by means of a fuel injection system. For producing the required pressure for atomizing the fuel, either air or mechanical means is used. If air is used, then it is called an air injection system, and if a mechanical means is used, it is called a solid injection system. Now, the air injection system is nowadays not being used so much and it is considered a bit obsolete. Why is it? This is because this system is a bit bulky and uses a bulky multi-stage air compressor. Now you can imagine fitting a bulky multi-stage air compressor in a vehicle. The vehicle in itself would become so heavy that it would outweigh its advantages. The advantages of an air injection system is for the air injection system is good mixing of fuel with the air with resultant high mean effective pressure. Another advantage is the ability of the fuel to utilize high viscosity which are at low pressure and then used by the injection with the solid injection systems. These advantages, however, are offset by the requirement of a multi-stage compressor, thereby making the air injection system useless and obsolete. A replacement of the air injection system nowadays being used is a solid injection system. This type of injection system is used in 99% of the commercial as well as performance vehicles that are running today. Now, in this system, the liquid fuel is injected directly into the combustion chamber without the aid of compressed air. Hence, it is called an airless mechanical injection system or solid injection system. Solid injection systems can be classified into mainly four types. First is individual pump and nozzle system. second being unit injector system, third being common rail, you all may know it as CRDI engines, common rail direct injection systems. Fourth being distributor system. Now all the above systems, these four systems that I have just mentioned, mainly comprise of the following components: the fuel tank, fuel feed pump, injector pump, governor, injector, fuel filters. That's it. These six things are required in every solid injection system. Now, I'll be explaining the basic function of a solid injection system, or a normal, conventional injection system, how these basically work. The fuel from the fuel tank first enters the coarse filter, the filter from which it is drawn into the plunger feed system, where the pressure is raised very slightly. Then, the fuel enters the fine filter, where all the dust and dirt particles are removed completely. From the fine filter, the fuel enters the fuel pump, where it is pressurized to about 200 bar of pressure and injected into the engine cylinder by means of the injector. Now, during this process, any spill over the injector is returned back to the fuel filter, fine fuel filter. The above functions are achieved with the components listed above: fuel tank, fuel feed pump, governor, injector, nozzle, fuel filters, etc. The types of solid injection system described in the following sections, in the sections that I just mentioned, differ only in the manner of operation, and the parts that I just mentioned are used in every type of solid injection system. They have the types of solid injection system, they differ only in the manner of, I'm sorry for that. They have no camshaft of their own, although they correspond to the potential energy inline injection pumps. Regarding the method of operation, in the case of large engines, the mechanical hydraulic governor or electrical governor is attached directly to the engine block. The fuel quantity adjustment is defined by the governor or controller, as you can say, is transferred by a rack integrated in the engine, inside the engine. The actuating cams for the engine individual PF single plunger pumps are located on the engine camshaft itself. This means that injection timing cannot be implemented by rotating the camshaft. So here, by adjusting an intermediate element, for instance a rocker between a camshaft and a roller tappet, an advanced angle of several angular degrees can be obtained. Single plunger injection pumps are also suitable for operation with viscous heavy oils like diesel, all the basic heavy oils other than conventional gasoline or petrol, as you can say. So guys, this was the working of a fuel injection pump, as I have just said, and that's all for now. Thank you. Stay tuned for more videos. Thank you.